Hey guys, 4.2, adding and subtracting matrices. Okay, this is going to be the second part because we did the first part on the previous video. So let's go ahead and take a look at the last examples here. Example 4, solving a matrix equation. So this one we are solving for matrix X given two other matrices. All right, so looking down here, we have solve matrix X minus this matrix equals that matrix. So we're going to treat this just like we would any regular equation. So we're solving for the matrix X. Right now we're subtracting this matrix, so the opposite is going to be to add that matrix to both sides. So we need to do that right now. This gives us 2, 3, 8, 5, -1, and 0. Okay, and so these are going to cancel each other out, and then you have x equals 10 plus 2 is 12, -4 plus 3 is -1, 6 plus 8 is 14, -3 plus 5 is 2, 9 plus a -1 is 8, and -9 plus 0 is -9. Okay, so we have now solved for matrix X. X would be equal to 12, 2, -1, 8, 14, and -9. All right, let's go ahead and take a look at example 5. Okay, so for example 5, it's asking us to determine whether the matrices in each pair are equal. Okay, so what we're going to want to do is to simplify each matrix. And also, in order for them to be equal, they have to be the same dimension. So this one is a 3 by 2, and this one's also a 3 by 2. So with respect to the dimensions, these two matrices are equal. All right, so now let's go ahead and see if there's anything we can simplify in matrix M. 8 plus 9, 17. Then we have -6, we have 0. 5, -1, and 0.7 repeating. Okay, matrix N, we have 17, 4 minus 10 is -6. Then we have 0, 5, -1, and then -7 divided by 9 is -0.7 repeating. So now we want to compare the elements. Do they match? 17, 17, -6, -6. They all match except for elements located in row 3, column 2. And the only thing different between those two elements is one is positive and one is negative. But if one's positive and one's negative, then they're not the same. They're not equal. So this one is no. And showing this work, showing these two matrices, is the equivalent of showing your work for this. You cannot just put yes or no and expect to get full credit. You have to either do the work or you have to use sentences, complete sentences, to explain your logic in your work. Okay, so let's take a look at B. Matrix P is already simplified, so let's take a look at Q. 27 over 9 is 3. 8 divided by 0.2 is 40. -16 over 4 is -4. -12 over 4 is -3. Okay, so comparing these two matrices, all of the elements are equivalent. So therefore, yes, these matrices are equal. Finally, example 6, finding the unknown matrix elements. Okay, so looking at I want to draw your attention to the textbook example before we do this other one. The ones that you have for your homework and your assignment are primarily like this one, okay? So I don't want you to panic where you are looking for the values of two different variables, but they are not part of the same equation. You are going to set the elements equal to each other. So 2x minus 5 equals 25. 3y plus 12 equals y plus 18. And then you solve those equations. Okay. Now let's go ahead and set these up. So we have 2m minus n equals 15. And then in row 1, column 2, we have m plus n equals negative 3. Now you'll notice row 2, column 1, they both have 8, so we're not going to bother copying those down. Those are obviously equal. And then we have negative 4m plus 2n equals negative 30. Okay, so we have two choices here. We can either use substitution or we can use elimination to solve for the variables. We have to solve for one of the variables before we can proceed. Does not matter which one. Let's go ahead and take a look at this second equation. We'll solve for m. So subtract n from both sides. M equals negative 3 minus n. Okay, so now what you're going to do is take this expression and you're going to substitute it into either this equation or this equation. It doesn't matter which, but you're going to have to substitute that in for one of those m's. The one on the left has a coefficient of 2, so let's go ahead and put it into that one. So 2 times negative 3 minus n, because m equals negative 3 minus n, and that's what's here, right? And then we have minus n equals 15. Okay, so now we need to distribute that 2, which gives you negative 6 minus 2n minus n equals 15. We need to combine like terms on the left. Negative 2n minus n is negative 3n. We need to add 6 to both sides. So that cancels out, and we have negative 3n equals 21. We want to solve both sides for n. Not both sides. We want to solve this equation for n, so we need to divide both sides by negative 3. And those cancel out, and you have n equals negative 7. Okay, so now we have half of it. But if you remember going back and thinking about systems, once you have that first variable solved, it's pretty much all downhill from there. You're going to take this value and substitute it into this expression. So m equals negative 3 minus a negative 7. Minus the negative makes that positive. Negative 3 plus 7 is 4. So you have m is 4 and you have n is negative 7. It's not a bad idea to check your answers in, let's say, this equation up here, just because we didn't use it, to see if it works. So negative 4 times 4 plus 2 times negative 7. Negative 4 plus 4 is negative 16. 2 times negative 7 is negative 14. Negative 16 and negative 14 is negative 30. And that is what we have here. So that checks out. All right, so that's it for 4.2. I hope you've learned a few things about adding and subtracting matrices. Please let me know if you have any questions.